I'm not obsessed with pigeons. I'm just annoyed how weird they are. They have so much time so that they choose to cross roads on legs when they can fly, but do not have time to sit and shit. I mean, millions of years of human evolution seems to come crashing down when they decide to use us, our clothing, and cars as a toilet. Believe it or not, some people consider it as a sign of good luck, as a sign of hope in disguise. Welcome to part 2 of the video on speed time distance. In the last video, we saw the relationship between speed time and distance. This equation can be used to find out the value of the third parameter if two of the three are known. These parameters describe the motion of a body. So if two of these three parameters are known, we can say that the motion is fully described and every aspect of it is known. We also saw a case wherein when distance is constant, speed is inversely proportional to time, and we solved two questions on this concept. Let's solve a few more questions on this concept and then we'll see what other cases we can encounter in problems based on speed, time and distance. Here we have the first question that reads, driving at his usual speed, Alex takes 1 hour more than what Brian takes in covering a certain distance. What we can do here is 1. Go about solving it the conventional way, and the other would be reverse checking answer choices that are assets in GMAT problem solving questions. First, let's see how we can approach this problem the more conventional way, because that doesn't seem time consuming either. If Brian takes t hours to cover 360 km, then according to the question, Alex takes t plus 1 hours in covering the same distance. But if Alex doubles his speed, he takes 2 hours less than the time taken by Brian in covering the same distance. Now, remember what we learned in the previous video. By the way, if you haven't watched that video, the link is in the description box. Please watch that first. In the previous video, we learned that if distance is constant, speed is inversely proportional to time. That is, if speed increases by a certain proportion, time decreases in the same proportion, and this is what inversely proportional means. So, here if speed of Alex doubles, the time that he would take to cover the same distance would reduce to half. We have also been given that at this speed, Alex takes 2 hours less than what Brian takes, or we can say it this way, that Brian takes 2 hours more than what Alex takes. Now notice here that the speed of Brian remains unchanged, and so does the distance. So these two terms essentially represent the same time. We can solve this to get t is equal to 5 hours. So the time that Alex usually takes is 5 plus 1, that is 6 hours. And since we have been asked his usual speed, we know the relationship between speed, time and distance. Now if we were to make use of answer choices, we would first want to look for choices that divide 360 and the quotient obtained is a whole number. We then go on to check if it checks all the boxes. That is, it confirms every information that we have been given in the question. Answer choices A, C and D divide 360 to leave a whole number as a quotient. So let's check option A first. We divide 360 by 40 and we get 9, which becomes Alex's usual time to cover the given distance. Brian, who takes 1 hour less, would take 8 hours to cover the same distance. If Alex doubles his speed, he takes half the time, that is 4.5 hours, and at this speed, he takes 2 hours less than what Brian takes. So Brian's time would accordingly be 4.5 plus 2, that is 6.5 hours, which is not the same as what we got earlier. So this answer choice can be eliminated. We go on to option C to reverse check it and proceed the same way. You will find that it substantiates everything what the question says. Let's see what we have in the second question. Tracy reached her destination in 7.5 hours, driving at 50 km per hour for the first half and at 75 for the second half of a journey. Now, since the distance for both the parts of the journey remains the same, that is half of the total distance, time taken in both the cases would be inversely proportional to values of speed. That is to say, since here we have speeds in the ratio 2:3, the time taken to cover the same distance in both the parts of the journey would be in the ratio 3:2, inversely proportional. So, accordingly we can say that the total time taken would be 3 plus 2, that is 5 units. And on comparing this total time to the actual value of time taken to reach the destination, which is 7.5 hours, as per the question, we get the value of 1 unit of time as 1.5 hours. I guess this way of comparing assumed values to actual values is clear. If not, I would request you to check my previous video on speed, time, distance to have a better idea as to how to use this to make calculations simple. Now that we have the multiplier, we can find the time taken to cover each part of the journey. So now that we know values of speed and time for both the parts of the journey, we can find the length or distance of the two and add them to get the total distance. We could also do this by reverse checking answer choices. But we need to be a bit smart in doing so and not end up having to check all the given answer choices, because that would consume a lot of time and defeat our purpose of using answer choices to save time. Now what we'll do is scan through the options and see what option would make the most sense to check first. The option that we have chosen to consider first, we halve it, and then using the values of speed given for both the parts of the journey, we find the time taken to cover each part of the journey. Add them to see if it matches the total time that Tracy took to reach her destination, that is 7.5 hours. Now, what do I mean when I say that we need to be a bit smart while choosing options? Let me help you understand. Notice here that the time that we have been given in the question is a rational number represented in decimal form. Why rational number? Because it can be written as a fraction 15 by 2, where 15 and 2 are integers and the denominator, that is 2, is non-zero. Now this decimal number, that is 7.5, could be a result of addition of two decimal numbers, which is kinda unlikely. I mean, it is not very likely that you would get the time values for both the parts of the journey in decimals, so that when you add the two, you get a decimal number that ends with 0.5. I hope you are getting my point. So the only way we could have a decimal number would be by adding a positive integer and a decimal number. Now, when we break the answer choices into two halves, one should fetch an integer and the other a decimal ending with 0.5 when divided by the given values of speed. With that said, let's now check the answer choices. What answer choice would you want to check first? Let's pick an option the value of which lies somewhere in the middle of the given options. So, let's start with 750. Half of 750 is 375 and 75, which is the speed at which she drives for the second half of the journey, divides 375 completely and we get 5 as quotient. 75 times 5 is 375. So we got one positive integer, that is 5. Now 50 divides 375 but not completely and leaves some remainder, which when converted to decimal form gives 0.5 at the end of the quotient, and this is what we are looking for. 50 times 7.5 is 375. Now, do we even need to add the two time values? We have already got 7.5 as one time value, which according to the question is the time that she takes to cover her entire journey. So clearly C cannot be the answer, but we can now definitively say that the correct answer choice is less than 750. So we know what options to look at. Let's check 600 now. But one thing we can instantly note here is that half of 600, that is 300, divides both 50 and 75 completely. So no way we could get some decimal number post addition. Now let's check option A, 450, half of which is 225 and 75 divides 225 completely. 75 times 3 is 225 and 50 divides 225 to leave a remainder 25, which when converted to decimal form does give 0.5 at the end of the quotient, because 50 times 4.5 is 225. On adding the two time values 3 and 4.5, we get 7.5, which is the total time taken to cover the journey as per the question. And we have our answer. By the way, if you find such content helpful, please give the video a like and subscribe to the channel if you haven't already. That would motivate me to continue doing this work. So that is it for this video. See you in the next one. Take care. Bye bye.